Hello everyone and welcome. Today what I wanted to do is I wanted to get started on chapter 11, which is going to be our statistics chapter. And so we are going to get started on section 11.0, which is actually a section that you can't find in your book, but it's going to be a section that's going to cover some basics that you are going to really need to make sure you're familiar with before we start diving into the topics that you can find in your textbook. Most of this information comes from Algebra 1, which was a couple of years ago, so you might want a little refresher. Let's start off with a couple of big fancy vocab terms. So now these big fancy vocab terms are about some ideas that you are probably very comfortable with, but the way that they look right now is a little bit scary. Let's talk about the first one, measures of central tendency. So a measure of central tendency is going to be something that is going to tell you about what is happening in the middle of the data set. Another term for the middle of the data set is the average of the data set, and another term for average is mean. The measures of central tendency, there are three of them, is the mean, the median, and the mode. Those terms probably feel very, very familiar to you. Just once again, they describe what is happening in the middle of the data set. So it is going to happen what exactly is in the smack dab middle. Now the opposite of that would be the measures of dispersion. Now to disperse means you're going to kind of, fan out or move away. And so measures of dispersion are going to talk about the same thing. Those measures are the range, which you've probably heard of, and the standard deviation, which you may or may not remember. These are going to describe how spread out the data is. Let's talk a little bit more about standard deviation. Standard deviation describes how far the data is from the mean. The mean is usually the most popular measure of central tendency, the one that people are most interested in, and the standard deviation is directly related to that mean right there. Let me talk to you a little bit more about this term. Deviation in particular is a fancy word that gets used sometimes, and it's not just a math term. So let's talk about it. Right over here what I have is I have a little bit of a graph. And what I want you to notice is that this graph has got this little bit of a curve to it, where it's high right here in the middle. And that is because this is where most of the normal things that people do live. So like your normal test scores, or the normal age when you got your driver's license, or the normal price that you paid when you bought your very first car. All of those things live right here. Yes, there are maybe some cars that are more expensive, or yes, there might be some people who got their driver's license a little earlier than usual, but those are rare cases, and the normal stuff happens here in the middle. That's also where the mean is. Now, if you're going to deviate from that, that means you're going to spread out or move away from that. So that can happen in both positive directions and negative directions. So let's talk about some deviations. Right here, what I have is I have an arrow that's going to represent a pretty intense deviation. And that deviation would be, rather than just going along your life like normal, where you get a job and you work hard and that's how you make your money, a deviation from that could be that you win the lottery and you never have to work again. So that would be a deviant. That would be different than normal, but it would be a positive one. It's on the positive side. Another deviation is this guy right over here. And this is, instead of going to class and working hard and studying like a normal student, what you might do right over here, a deviation would be that you might cheat on a test. That would be a negative deviation, and that would be different from normal. So once again, you can deviate in the positive direction or in the negative direction. Cool. So hopefully that'll help you out to understand standard deviation a little bit more. We're going to be talking about it more today. Let's go back and refer back to mean, median, and mode for a couple seconds, because although you might feel familiar, you might also need a little bit of a brush up on those. So let's talk about that. Right here, what I have some very clear information about your measures of central tendency. So mean, our most popular measure of central tendency, is oftentimes called the average. It is going to be the number. It is going to be the sum of the numbers in a data set divided by the number of terms that they have right there. In a math class, there is a symbol for mean because it is so popular, and it is this symbol right here with an X and a little bar over the top, and it's called X bar. Here is the formula for mean. What you're going to do is you're going to take all of your data points and you are going to add them up, and then you're going to divide by the number of data points you have. The second measure of central tendency is the median, and the median is the middle number, and it is very critical that when you're looking for this middle number that you have your terms in order. I will stress this quite often to make sure that it's always happening, and as long as you follow what I do, you'll be in great shape. Another important fact about median is that when you're looking for the middle term, sometimes there might be more than one, specifically two. If there is two middle terms, then what you are going to want to do is you are going to want to find the mean of those two middle terms. And when you do that, that will give you a new median, which may never actually exist in the data set. Third one, and this is the one that most people forget, but it's very easy to remember, the mode. The mode of a set of numbers is the one that occurs most often. Now, when you're calculating mode, a lot of people are looking for one number that is going to occur most often, and that happens quite often, but it is also possible that no number occurs most often, and that means there is no mode, and that's okay. It is also possible for you to have many modes, or more than one mode, and that is possible when more than one number shows up the same exact number of times. Let's do an example problem with some of these measures of central tendency. So what I have right here is it says Mr. Claypool's 2 geography classes took a quiz on Latin America, and their scores are listed. So we have class A on the left, and then we have class B on the right. What we want to do is we want to find the mean, the median, and the mode of this data set. This is something that students ask for all the time. What was the average of the quiz? And so they want to know. So the first thing that I would suggest that you do is something that I mentioned earlier. When you're given a data set, especially if it's a jumbled one like Mr. Claypool's Class A, you are going to want to make sure that you are writing it out from least to greatest. So I have copied down all of these numbers because they're all straight, but this set right over here, Class B, this one is all garbled up. And so what we need to do is we need to make sure our lowest number is first, and then our highest number is last, so that it is in the correct order. All right, now that you've written them all down in the correct order, now let's calculate mean. So for mean, what I'm going to do is I'm going to copy them down again with plus signs this time, and then I want to add them all up. When you add them all up, you're going to get 171. Now that's pretty good, but we need to do a little bit more. You also need to divide by the number of students in the class. So right here, if you're counting students, you will find that there were 9 kids in the class. So that means you need to take your sum of 171 and divide it. And that means that the average score was a 19. For the Class B, same kind of thing. I've written down all my terms, and I'm going to divide. In Class B, there are only 8 students. When I add them all up, I get 170. And when I divide by 8, I get an average of 21.25. Which class did better on the quiz? Class B. The average is higher. Let's talk about median. Median is going to be the middle term. So when you're looking for middle terms, this is why I like to write things down. When I'm looking for middle terms, what I do is very quickly and easily, I cross things off on the left and on the right, and I move my way towards the middle. And what I find is that there might be only one number left, and that number becomes my median. In my second class, Class B, as I'm moving towards the middle, what I find is that I actually end up with 2 terms here in the middle. Now they're both the same, so it's pretty obvious as to what the median is going to be, but I still want to show you the work. When there are 2 terms in the middle, you are supposed to take the mean or the average of them, which means you need to add them together and divide by 2. 22 plus 22 is 44, and 44 divided by 2, it goes right back to being 22. Once again, Class B has the higher measure of central tendency, so it looks like Class B has done a better job on the quiz. Let's talk about mode. Mode is the most popular. When we go back to our original list for Class A, you can see that 17 shows up more than any other number because it shows up 3 times, which means that it is the mode. For Class B, 22 looks like it shows up more often than any other number, which means that it is the mode for Class B. Super. Let's talk about the measures of dispersion now. So our measures of dispersion are only 2, but they don't have a nice little rhyme or trick that goes with them. The mean, the median, and the mode all start with M, which is great. Our measures of dispersion are range and standard deviation. Range is an old one. It is technically called the distance from the lowest value to the highest value. But a much quicker way to think about that is it is the maximum value minus the minimum value. This is the way that I always think of it, and it always works well for me. if your numbers are written in order from least to greatest, like I like to do, it is always the last number minus the first number. And that's true here, the last number minus the first number. Not up here. 21 minus 22 is not the range. Now, standard deviation is far more complicated. And because it is complicated, I'm going to introduce you to it. And I'm going to show you what the formula looks like. But I'm not going to use it, because I have a much, much better way for you to work with the standard deviation that I think that you'll find a lot of success with. And so we are going to look at it, and then we're going to say, that's nice, and we'll use another technique. It will use all the same properties, but I think it'll just keep you a little bit more organized. So here's the deal. For standard deviation, it has a shorthand notation. It uses this Greek letter right here, which is called sigma. We have seen another sigma in the past, which was this one. That's capital sigma. This one's lowercase sigma. And so we are going to be using this one to represent standard deviation. Now, if you have a data set that includes data points like these ones, then you are going to calculate standard deviation in a little bit of a lengthy process. First thing you need to do is you need to take each data point and subtract the mean. Then you need to square each data point. Then you are going to add up all of those squares that you came up with. And then lastly, you are going to divide, just like we do with mean, and square root. So there are quite a few steps, specifically 6, that you need to go through when you're calculating standard deviation. In order to help you keep organized with those 6 steps, I have tables that I think are going to be very, very valuable to you. So let's try this example out with the tables. And you'll notice that we're going to go through the same 6 steps, but it just won't look like this, because this, I think, looks particularly awful. So we're going back. This is Mr. Claypool's 2 geography classes again, Class A and Class B. And this time what we want to do is we want to calculate the measures of dispersion. So let's talk about range. Range is very quick and very easy. Once again, you want to find the maximum value, which would be 25, and then you want to subtract the minimum value, which in this case would be 15. When I calculate the range for these guys right here, it goes very quick and it's very easy. I am going to get 10. Okay, now let's do the standard deviation. So step number 1 for standard deviation is actually calculate the mean. We did that on the front side. For Class A, I know that the mean was calculated to be 19. And so I don't have to calculate that a second time. I'm just going to copy off myself from the front side, and I'm going to plug in some 19s right here. So now what I have for my first column of the table, I have every single data point, once again, from least to greatest. Then I have a column with just the mean in it. Now, if you look at our third column right here, it'll give you a hint as to what I want you to do next. Notice the subtraction sign right here. What I want you to do now is I want you to subtract all of these number combinations that we have in order. So that means 15 take away 19, not 19 take away 15. So 15 take away 19 is actually negative, and it is going to be negative 4. Then 17 take away 19 is also negative, and it's going to be negative 2. 18 take away 19 is still negative. I want you to notice that even though they're negative, they are changing, and they're getting closer to 0. Now, after this, 21 take away 19, now we're going to start to see some positive values, and I want you to notice that they're changing as well. They're growing. So we started off far away from 0, we got closer to 0, and then we started traveling away from 0 again. Now let's talk about the final column of the table. In this final column of the table, once again, you'll notice a hint. We already did the subtraction, so those parts all taken care of. The only thing that's new is this power right here. So now what I want you to do is I want you to take a power of everything that you just wrote down. Do you see how organized this is? It goes very smoothly as long as you stay organized. Now be careful here. Negative 4 squared needs to be typed into your calculator with parentheses. Otherwise, it will give you the wrong answer. I would actually urge you to do this work in your head, because I know that you're very smart and you can take care of negative 4 squared without making a mistake, while your calculator might make a mistake. Negative 4 squared is 16. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0, and now we can relax a little bit because we're into our positives. Okay, so now when you've completed the table, unfortunately you're not quite done with standard deviation, but you are super close. So the next couple of moves we're going to do next to the table, not in the table itself. So here's what we need to do. We are now going to take every term that we had in this last column right here, and we're going to add them up. When I take every one of these numbers and I add them up, I am going to get 78. Now that's a very important number, but once again, it's not our final answer. We need to do two more things to this. Thing number one is you need to divide by the number of kids in the class. And I don't know if you remember from the front side, but there are 9 kids in the class A. And the other thing that is very important for standard deviation is you need to take the square root. So when we do our division first, which is what you should do, follow your order of operations. Division first means you're going to get a decimal, 8.67. Then, after that, now you need to square root. And when you square root, you are going to get your standard deviation, which will be 2.94. Fill in the table, add, divide, or square root, and then you will have your standard deviation. Here's what I'd like you to do. I'd like you to pause the video right now, and I'd like you to see if you can calculate the standard deviation for Class B. I'll show you the answer for that standard deviation in a couple of seconds. Pause the video now. All right, here is the answer for Class B. Your range is going to be 25 take away 16, which is going to be 9. Your old mean that we had from the front side was a decimal. It was 21.25. You're going to do your subtraction, and you'll have some negatives. You'll have some values that are as close to 0 as you can possibly get, and then you'll have some positive values down here. Everything gets squared, and now everything is positive. You'll add everything up. You're going to divide first, and then you'll square root second. Then you'll have your standard deviation. Comparing these is interesting as well. On the front side, the class that had the highest mean or the highest median had the best scores. On those dispersions, please remember that the bigger the number is, that means the further it has moved away from the center, and that is bad. So that means that if you have a high standard deviation or a high range, that's bad. So this number here, 10, is not as good as this number here, 9. This number here, 2.94, is not as good as this number here, 2.77. Because the range and the standard deviation of Class A is greater, that means that its quiz scores are more spread out. They are not as consistent. You might notice that there are some very low scores and some very high scores in Class A. In Class B, the scores don't go as low. They are closer together. And there are more of them that are bunched up very, very tightly in the realm of the 20s. And there are not as much of a bunch in this problem right over here. Let's take that a little bit further. So now all of this is supposed to be review material, and now what we're going to do is we're going to dive a little bit into some new material as well. What I want to do is I want to analyze Class A a little bit more carefully. We found out today that the mean of Class A was 19, and that the standard deviation was 2.94. Now, a lot of times people are very capable of calculating standard deviation, but they have absolutely no idea what it means. So I want to show you using that drawing that I had shown you earlier. Do you remember the drawing? This was the drawing that I had shown you that was talking about what is normal or average. And I had said that when you deviate from the drawing, it can be a deviation in the positive direction or a deviation in the negative direction. So now, according to our calculations, the most average and normal score to get on our quiz that we took was a score of 19. So, sometimes people want to know, am I average, am I normal? And so the answer to that question would be, well, did you get 19 on the quiz? And if somebody says, no, I didn't get 19, but I got 18.5, am I still normal or average? And so that is where things become a little bit confusing. They don't quite know if they're good enough to be normal. And so I want to talk to you about that. That's where standard deviation comes into play. Hitting one particular target to be determined as normal is difficult to do. It would be much, much easier if there was a little bit of a wiggle room range that would allow you to kind of consider yourself normal. So let's do that. If you take your mean of 19 and you subtract the 2.94 standard deviation, that will bring you down to 16.06. If you take your mean of 19 and you add your standard deviation of 2.94, that will give you a value of 21.94. So now let me make this a little bit clearer for you. You are now considered normal, not if you hit exactly 19. That would be very difficult to do. But rather, if you are somewhere in the ballpark between 16.06 and 21.94. All of these values are hovering right around 19, but it gives you a little wiggle room. So even if your score was a little lower, you're still considered normal, and even if it's a little higher, you're still considered normal. In our class, all of these scores right here are all within one standard deviation of the mean. They're all bigger than 16.06 and smaller than 21.94. There's a lot of normal students. This student is particularly low, and only these two students are particularly exceptional. So that is a little quick analysis that shows you the point of standard deviation. This is part 1 of 2 videos on section 11.0. Please make sure you watch both of them.